We have Adam Naids, who's going to talk about developing Artemis geology tools. So Adam, if you're there, go ahead and take it away.
I'm here. Can you hear me okay?
Yes, fantastic.
All right, great. My name's Adam Naids. I'm the Deputy Project Manager for our Artemis geology tools, and also our team's point of contact to you all, the science community. Also with us today is Heather Bergman. You may see her name around. She is our project manager. So let's go to the next slide. Three points today. One, we want to tell you what we're doing, give you a status of all the work that's been going on this year, and talk about what's going on in the future. The next step. All right, great. So our team, our EVA tools team here at Johnson Space Center was funded and charged to go start developing the next generation of flight-ready Artemis geology tools. So we were given this challenge back at the beginning of this fiscal year, and the challenge was to go take an initial toolkit and get it to a critical design review level in 1 year. So you can see the list of tools that made the cut. The idea was to start with tools that we know have a high likelihood of flying based on Apollo, right? These are your simple tools: your hammer, rake, scoop, tongs, extension hand. All these things were flown in Apollo. This isn't an all-inclusive list. It's just something to get us started, to build the relationships, to find the gaps, ask the questions. And so far, it's been going really, really well. We worked together with our colleagues over in the Ares division here at JSC to come up with this list, and on pretty much the rest of the project as well. So I'll talk more about that. Next slide. All right, so we did a lot of research, like a lot, and did a lot of reading. We reached out to the JSC history office. We reached out to the data center that Ares has. We spent a lot of time on the Lunar Surface Journal website, and we are taking all of that knowledge in, lessons learned, what worked well, what didn't, and we're applying that to our Artemis tools designs right now. We get a question a lot that says, why aren't we just reusing the Apollo tools? Just build a print and fly them. I'll tell you, in some cases, we are using designs from Apollo. We track the evolution of some of these designs, and they remain stagnant over the last few missions. The drive tube is a good example of that, and we have no reason to change them. We are having to analyze them for new environments and new load cases potentially, but some cases we're using what worked and what's known. But we also want to make the tools better, and so with 50 years of knowledge in material science and things like that, we want to make sure that we're making those upgrades. Additionally, as you heard yesterday, we have a brand new spacesuit, which has a much more mobility and different visibility, and so we're making sure that our tools are optimized to be used with that spacesuit. Next slide. So I just want to go over like a notional concept of operations here. These are just high-level stuff that are still in work, obviously, but they're gonna fly our tools to the moon somehow, whether it be on the HLS vehicle, or there's been discussion about potentially launching them on Eclipse payload beforehand. TBD what exactly is going to use, maybe a combination of all of those options. The contingency sampler will be used like in Apollo to grab a sample pretty early on in that first EVA to make sure we get something in case we have to leave in a hurry. We're going to carry tools on the suit itself. We're going to carry them on a tool carrier. We're going to carry them when we have a rover on a tool carrier that's attached to that rover. We're going to transport all of that equipment. You all might have instruments that you want to fly, and we'll have to integrate at some point to make sure that those are there's interfaces for those on these tool carriers. We're going to go take samples from a lot of different places. We know that that's an that you're interested in that, like the last slides talked about. And so we'll get those samples. We'll put them in bags or in vacuum sealed containers, and we'll bring them back to Earth for you guys to study. We fully understand that every pound that our tools weigh is one less pound of samples that we can get back. And we take that responsibility very seriously. We are going to optimize our tools for mass. We talk about it almost every day. It's a big deal, and we want to make sure to maximize the samples that you all get back. Next slide. All right, so requirements. So we're a flight project, which means we have to go through the NASA, project management lifecycle and flight certification process, and that starts off with developing requirements for the tools. And so, at the last Lunar Surface Science Workshop, NASA announced their science goals for Artemis, which was a great start. But the kind of the breakdown of those into smaller requirements is still kind of in work. But we knew that lunar sample return is going to be a main objective, and so that's why we felt comfortable kicking this off. But to kind of maintain this aggressive schedule, we've been working in partnership with our colleagues at Ares to help us define requirements and to come up with numbers to use. And we understand there's a little bit of risk in this. Our program, the EVA office, understands that there's risk in this, because what we really want to make sure that you all in the science community have an opportunity to impact this. Because at the end of the day, these are for you. We are making geology tools for you that we can bring lunar samples back for people to study for decades, and that responsibility is not lost on our team. So those opportunities will exist, and we're not gonna finalize our tools until we make sure everyone gets a chance to do this right. But we're also trying to lean forward to meet some challenging deadlines. So we're gonna find a compromise. Next slide. I'm not going to spend a lot of time here. We're getting you a lot of different samples. You can get float samples, regular samples, core samples, all of that. We're prepping for all of that. Next slide. Contamination control. Julie talked about it, and it was talked about in the last set of charts as well by Jamie. And this is something that our team is new to, and we are trying to get smart. And so we are reaching out to people, the few people on Earth that have taken part in sample return missions. And so we met with folks from the OSIRIS-REx team. We met with folks from the Mars Perseverance team. We were continuing those discussions. We're doing tests ourselves. We are planning to do this and do it right. So we want to minimize contamination, or make sure that we have good archives to support the contamination knowledge part of this. So we understand this is big, and we're gonna implement a plan. Next slide. Designing tools that an astronaut in a spacesuit uses is challenging. You can't just go to a hardware store most of the time and get a tool off the shelf. We have different environments we have to work within, different load scenarios. We have to design it for the glove, which every time you squeeze it, you have to deal with hand fatigue because you're going against the pressure of that suit. And so those are things that we have to design into our tool to make sure that it works. In particular, at the South Pole, the temperature is a big deal. It's very cold, and we might have to make some. There's going to be some operational considerations to do that. Next slide. So here was the schedule for this year. We had a kickoff meeting in October, and we had our requirements review in February, and we're going to have another milestone review here in October to show the progress that we've made so far. But this isn't the end for these baseline tools. There will be some time next year to continue developmental testing, continue getting input from astronauts and scientists alike, make sure we get the best product.
One minute, Adam.
Thanks. Next slide. Like I alluded to before, these are not the only tools that are going to be made. There's going to be dozens of tools and instruments that are going to be made. Some will be made by our team, some will be made by others around the world. And we are just excited to be a part of this we don't take our responsibility lightly, as I said earlier. So I'm excited to be here today to kind of listen and hear from you all directly about what is interesting to you, and hopefully we can talk a little bit more in the discussion later today.